everyone. Today we are going to explain you about string sorts. But first we need to talk a little bit about just what strings are. So what is a string? String is just a sequence of characters, and it's actually a very important fundamental abstraction that's been with us from the beginning of information processing. So pretty much everything we communicate is a string, like email or chatting with someone. The first string algorithm that we are going to look at is actually the basis for several more complicated algorithms. It's called key index counting, and it's very useful in particular special situation. Let's take a quick review of where we left off with sorting. So we considered a number of algorithms, starting with insertion sort and then merge sort, quick sort, and heap sort. And we got the point where we could define an algorithm that's heap sort that guarantees to sort n items in time proportional to n log n without even using any extra space. Unfortunately, not stable. And all these algorithms are useful for any type of generic key as long as it implements to the compare to operation. And not only that, we proved that any algorithm that just uses compares has to use the number compares proportional to n log n. So in a very important sense, merge sort or heap sort, for example, are optimal. You can use asymptotically fewer compares for either one, and with heap sort you can use less extra space. K-index counting. The goal of this algorithm is sort an array of n integers between 0 and r-1. In our case, r is 6. As you can see, a, b, c, d, e, and f. So we have 4 loops. The first loop is used to count frequencies of each letter using k as index. And the second loop is used to compute frequency cumulates which specify destinations. So we have an array, and then in second loop we count the frequencies. Like in our array we have 2 A's, 3 B's, 1 C, 2 D's, 1 E, and 3 F's. And in third loop we create the auxiliary, like access cumulates using k as index to move items. And then in the fourth loop we copy back into original array. So let's solve this example. In our case it is a second loop, and this is the third loop. So 6D will be here, and after that 6 will be incremented to 1, so there 6 will be 7, and then 0A, and A0 will be 1, and after that 5C, C will be 6, after that 9F, 9 will be 10, and 10F also. F will be 11, and 2B, B will be 3, 7D, D will be 8, and 3B, and B will be 4, 11F, F will be 12, and 4B, B will be 5, 8E, 8 will be 9, and the last one is A. First, A will be 2. So that's all.
LSD algorithm, least significant digit first string sort algorithm. The main idea of this algorithm is consider characters from right to left and stably sort using this character as the key using k-indexed counting algorithm. As you can see, we have 6 words: DAB, ADD, CAB, FDD, FAD, FEE, BAD. And you can see the words are in same length because it's necessary for LSD algorithm. And then let's sort these words together. At first, we will assign D to 2, and we will choose the third column, and we will sort this by k-indexed counting algorithm, and we will get this B, B, D, 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 E. And we will decrease D to 1, and we will choose the second column, and we will sort this by k-indexed counting algorithm again. And we will get A, D, E. And we will do same thing, and we will decrease D to 0 and choose the first column and sort by k-indexed counting algorithm again, and we will get only sorted words. The LSD algorithm is stable because k-indexed counting algorithm is stable. And let's proceed our code of this algorithm.
So let's continue. As you know, here you can easily find and dual and string sort Java application. So I downloaded it for you before. Let's open it. And here, as you see, you can write here some input, some strings or some text, and you know, here you can choose 3 types of string sort algorithms. For example, LSD, MSD, radix quicksort, and just sort it and look for the Java implementation and see how it will be sorted. So let's start from first LSD string sort. So here I prepared for you some strings. Let's copy and paste it. So let's sort and look how it will be work. So let's take pause. Here I wanna give you some little explanation. So how LSD works. As you know, it will sort from right to the left, I mean from the end to the beginning. For example, here you can see the letter B. The first word is the DAB, and the last letter is B, which will be first in the LSD sort. In count array, it take the next letter after B. For example, here B, there will be C, and write the frequency count. For example, here will be the first time, it will be the index will be 1. Here will be the next letter will be D, and here it means that here will be letter E and with index 1. Also the next will be again B, but index will be 2, and so on. So let's look it. So as I said, it will be E and 2, and again 2. E will be F, D, again D, E will be F, D, D, and B and E. And in the end, just added the first letter, which you can say B with index 0 because there are no any A letters. After this, it will be accumulate all this index. I mean, just like sum up. For example, and in B's index will be just sum of this index and the previous. It will be 0. In the C indexes will be the sum of the B and the C indexes. It's 0 plus 3, it's 3. And D will be again C plus D, 0 plus 3. And E will be D plus E. It means that 3 plus 6 will give us 9, and 9 plus 3 will give us 12. So here, as you can see, just accumulated like 9 plus 12. So and here we have temporary array which write the which will have this number of array indexes which we will have in the end. For example, 12, it means that will be 12 indexes. And the idea of LSD string sort, it just look or give us a place of each words. For example, it's say, for example, in which place must we must put, for example, words fee or words bed, and by these indexes we can easily find it. So first of all, it will be start with the first letter from the first words, and look for the last letter and look for the indexes of the last letter. For example, the first words is dep, it's look for the index of P, and index is 0, it means that it's located in the zeros indexes. Also, when zeros index is not empty, it will be incremented by 1. It means that the next words which will end with letters B will be located in the first indexes. So it's incremented by 1, next add and increment it and take place. Next cap will be in the first and just increment it and just put on the order. So you can easily see how it will works. So as for Java implementation, here you can look at the, as I said before, how it will compute frequency counts, and also start from the end to the beginning, from the right side to the left, and compute cumulates, then transfers in the library and again copy it back, and after all this operation it will be sorted. So the idea of the LSD quicksort seems very easily, and here finally you can see how it sorted.
So the next algorithm is the most significant digit first string sort algorithm. The second name of this algorithm is reverse LCG. The main idea is consider characters from left to right and stably sort using this character as a key, using k-index counting. So the goal is the partition array into R pieces according to first character and recursively sort all strings that are start with each character. So we have an array, and after that we will sort by the first column, and then as I said before, in this algorithm we also use k-index counting. So in second loop we count frequencies, and the third loop we count the cumulates. So like 2A's, 5B's, 6C's, 8D's, 9E's and 12F's, and then we divide it into subarrays, and we sort it recursively. So let's look for the demo of this algorithm.
Let's continue and try to understand the next MSD string sort algorithms. Let's start. So what's the idea of this sort? It's also like LSG sort, but start with first letter and not just sorted by the first. It's start with first, and after the sorted from the first, it look for the next, second, and so on. So let's look at it's also like LSD. Try to find counting using k-index counting, and also accumulate it. I like just sum up and take place after found its place of each word. I just copy it back and started from words which start with A letter and B, C, D, E, and so on. So like let's look at just slow. As you can see, there will be like this, and then it will be sorted by the second letter, but not all words, just from A letters. It will be, for example, at and ace. Next will be bet, B, and bet. Let's look at just from two words, just found and just accumulate and change, like as you can see. So as for Java implementation, Java code, it's also like LSD, but it's recursively sorted after the first and the second letter and so on. So idea also like LSD, but it's not sorted by just once. It's sorted starting from the left to the right, and start with the first and continue up to the end. And here you can see this how it will be sorted in the end. Just let's increase the speed, and finally you can see it how it will be sorted. So it's now in the D letters, and in the end it will be in F letter. So just let's increase. So just sort all words starting with F, and after accumulate it's found its place, and so as you can see, let's just let's end it. Let's look, and you can see how it will be sorted. Just take, you can see it before how it will sort. So it was MSD string sort.
Let's look at another MSD example with string with different lengths. And as we said before, we use k-index counting to sort the first column, and after sorting first character each of strings, we sort recursively subarrays with k-index counting algorithm. After all, we get the sorted strings. Let's talk about string quicksort.
The main idea of this algorithm is familiar with Survey Standard Quicksort. If you don't know about Survey Standard Quicksort, please learn about it and come back again. The main idea of this algorithm is doing survey partitioning on the bit character. The advantage of this algorithm is less overhead than array partitioning in MSD, does not examine character equal to the partition character. As a partitioning item, we took every time the first string, first character, and we use first character to partition into less, equal, and greater subarrays. After partitioning first characters, and we recursively sort subarrays, excluding first character of 4 middle subarrays. As you see, we took the first elements of the subarrays as a partitioning item, and after first partitioning, we recursively sorts first subarray, and next step is sorting middle subarray, excluding first character, and each time we recursively sort subarrays equal, greater, and less subarrays. At the end, we get the sorted strings.
Next, look at the demo how our Radix quicksort will be sorted. So idea, it's like as you know, quicksort also take like a pivot, also start with the first and look at the pivot index and just compare it and change place. So let's decrease and see how it works. As you see, the pivot is, and just look at, and if it will be bigger than the pivot, it take place on the end, and pivot will be decrease. Let's see for the words FAD. It will be bigger than the pivot and take place in the end, and pivot will decrease. And just look for the all words. And after take first partition, it's take the second, and so on. Go to the when it will be sorted. As for Java implementation, also like our quicksort algorithms, like decide which partition to put current element, for example, and also sort its partition. So here, as you can see, it will be sorted. Let's increase it and look how it will sort. Also, we have there are some indexes. Also, try to first of all start from the all indexes, and after it's decide which partition will be, and just for example here in this example it starts from 0 to the 5th index, and also use the pivot as the 5th element index, and look at the pivot and compare it, just change position. So let's look. It seems that it will be already sorted. Let's look. So the last two words is, and so it will be sorted. Seems like it will be sorted. No. Here also words C, D. Here E must go up to the F. So let's look how it works. So IDE also like quicksort algorithms. Just use the logic of the quicksort. Here you write starting index end and choose the pivot. Also here let's look for the D letter, also F, and you see that E will go up to the F. So here FAD must go to the it will put after the E. So let's look at. So as you can see, in the end F will be upped, and so here it just sorted. You can see how it will be recursively run it. So it will it was the simulation of all three types of string sort: LSD, starting from the LSD, then look at MSD, and ended with the Redux three-way quicksort. So it was all for today. We wanna say thanks for your attention. We hope that these videos were so useful for you. Please subscribe this channel. Also recommend to your friends. Give some likes or write some comments, and see you next time.